That's fantastic. All right. So when I was young, I had a fascination with hackers. I grew up in the 80s. I saw the movie War Games. Did anyone see that movie? Oh, wow, a bunch of people. You should definitely watch it again. It aged so well. It's a movie about machine learning. There's a bit of hacking. There's a bunch of things there, but it really actually aged well. I was surprised I watched it just because I've been reminded of that movie. So I was watching it last weekend. Maybe next year, Star Trek, we should do like a War Games video presentation. So I grew up with that, and I really, when I was young, I was hoping that I would grow up as a hacker. I would be like some sort of a modern cyber Robin Hood or something. I would do like some stuff, but just for good, right? I didn't want to be a bad hacker. I imagined myself, wearing a hoodie in a dark room, something like that, like just frantically punching at a keyboard all day long. And as I was growing up, I did a little bit of things. In the 90s, I had video games or PC games, and I would open up my save games with XT Pro and look at it. It was a hex editor, and I could kind of figure out what was in there. And I was like, oh, this is the amount of money that I have in SimCity. So I would change the value, and I would open up the game, and boom, I had like pretty much unlimited money, which was really cool. It also really ruined the fun out of SimCity for me. But I really had a lot of fun trying to hack into those save games and doing all that stuff. So I was really hoping that I would eventually become a famous hacker. But then, life happened. I grew up, and I realized that, that's never going to happen. I've realized that being in computer science doesn't make you a big hacker like that. And I've decided that, that's not what I'm going to be. I'm never going to be a hacker extraordinaire. I'm never going to hack into NSA's database and trying to find some information. I mean, I do wear a hoodie. I'm in a room with no window, and I'm just about to start typing on my keyboard, so I guess I'm kind of halfway there. But not exactly as I originally imagined. And I now work at Auth0. I'm a technical evangelist for them, so I go to a lot of conferences. And recently, I went to a talk about OAuth, so top 10 security vulnerabilities. And injection is always there. It's always one of the top. It's been there for years, and people still are not careful about injections. So it kind of reminded me that you can do those little hacks. It's kind of fun. So every now and then, I find a site, and I'm like, so you can add a comment in the blog or something, and I'll put a script, alert, poop emoji. It's fun. It's harmless. And I'll usually send a message to the webmaster or whoever who owns the website. But it's fun. It's fun to do those little tricks. And then, like I said, I've been a technical evangelist for about a year now, and I've been talking about OAuth and JWTs and how those will help you to make your website secure. And then I started realizing maybe there's also little hacks that we can do on JSON Web Tokens that actually won't make it as secure as I originally thought. So I started looking into that, and that's what I realized, actually. If you don't implement JSON Web Tokens the right way, you can actually make your site a lot less secure. And you can actually give access to everyone to all of your data. So you have to be really careful about that. So this is what I'm going to talk about today. I'm going to give you a little bit of the hacker's point of view. There are websites out there, surprisingly a lot, that do not have a good implementation. And they do have those vulnerabilities in. I'm not going to take those websites as an example. So I've built my own API, my own authorization server for the purpose of this presentation. And I'm going to use those to kind of demonstrate how you can attack those websites. So our agenda today, I'm going to talk a little bit about OAuth. I'm going to give you the big lines, some of the major flows that are used in OAuth. I'm going to introduce you to JSON Web Tokens, just in case you're not very familiar with them. We're going to see the anatomy, and it's kind of important to understand the different pitfalls that I'm going to introduce afterwards. All right, so let's get started with this. First, let's talk about myself. Well, that's a big picture of my face. So I'm Joel. Hi. I'm from Canada, very proud French Canadian. Currently live in Toronto. As I mentioned already, I work as a technical evangelist at Auth0, which means that I get to learn about cool stuff. I get to just play with technology like I did, and then I go at conferences and present what I've discovered. I also author a few courses. I have some on Udemy and Egghead, mostly around authorization and authentication. So if you're interested, you can take a look. And I'm also a co-organizer for Nomad.js, which is a meetup for people that don't have a local user group or that cannot attend the local user group for some reasons. If you're interested in knowing more, nomadjs.com, and I am desperately looking for a speaker in May. So, if you're interested, come and see me. I absolutely love Twitter. I get very excited whenever I have a Twitter notification. I saw that Steve just posted something right before the talk. I was super happy. So if you ever have any questions, Joel, with 2 underscores, Lord, it's like the worst Twitter handle ever, but it's there. By all means, send me a message. I usually respond really quickly. Also, I have stickers. I'm really passionate about password. I think that people should not use passwords anymore, and we should find solutions. But in the meantime, there are some little things that you can do. So I have passwords to remind you that passwords are like underwear. Don't leave them on your desk, and so on. They're right there in the front, so you don't even have to talk to me. Just come and grab some. But I'll be super happy if you tweet about them. All right, OAuth. What is OAuth? So OAuth is a protocol basically that describes how communication should be done between different machines. Right? When I first started looking into OAuth, it's like just a bunch of charts with arrows and a lot of terminology and vocabulary that I wasn't familiar with. And it took me quite a while to kind of understand what it was. But essentially, what it is that it just describes how the information should flow from one machine to the other to help with authorization, authentication, and delegating access to different resources. What they call grants is just a different flow of communication between the machines. And you use tokens to actually share this information. So a token is a piece of digital information, and I'll come back to tokens afterwards. So all in all, OAuth is a very loose standard, but it kind of just describes those flows. I'm going to show you 2 of the major flows in OAuth, the one that you would typically encounter in your application. There is a lot that are available. There are some very specific for very specific scenarios. If you do IoT and things like that, it's completely different. But I'm going to introduce you to the authorization code flow. So the first thing that you have here is a user that is trying to access, the user is at the bottom left, trying to access a web page. That web page connects to a server, and that server will in turn try to connect to an external API. You would see that typically on a web page that is served by that server in the middle, and the server tries to access some data on Twitter, for example, and tries to do some analytics or something to show on your dashboard. So it tries to access Twitter on your behalf. So how does that work? So the first thing, the server will check if you are authenticated or not on the API. If you're not, you're being redirected to the authorization server, the authorization server for that specific API. The authorization server will try to validate your identity. It will use different ways to do that. It could be a username, password form. And once you are authenticated, it will redirect you back to the browser, and it will give you an authorization code. So that authorization code is just a tiny little string that can be used. It'll live on the server for just a few seconds, so you have to use it very, very quickly. So send that back to the server, and the server will then ask the authorization server to trade that authorization code with an access token. Once you have an access token, you can actually access the data. So the access token is basically the key to the API. So once you have this, you are able to do some requests on the API. So you get the data back. So the important part here is that your front end never had access to any of the user information. You never touched the user credentials. You never touch the access token. Because if you lose this access token, basically anybody that got hold of that token can impersonate your users. So you have to be careful about that. You also didn't have to deal with the user credentials, which is a good thing, because it's a very sensitive piece of information, and maybe you don't want to deal with that type of information. So it can be very useful for that. In most cases, though, this is not exactly the type of architecture that we're building. More typically, what we see is something like that. So we have the user. We have a single-page application that uses React, Angular, whatever view. And you don't have that server in the middle. Your single-page application tries to access an API directly, typically your own API. So you're trying to get that data without that server in the middle. So what will happen is that your front-page application, in this case, will be responsible of validating if the user is authenticated or not. If he's not, redirect them to the authorization server. The authorization server goes ahead, does that request, tries to validate if you are authenticated or not. And if you are authenticated, it will return you the access token. So once you have this, you can actually make your request to your API and receive the data that you've requested. There's recently a lot of controversy about the implicit flow. There are tiny little things that you should be careful about in the implementation. I won't go into the details of those, but when it actually came out, people were like, don't use the implicit flow ever again. Turns out it's not that bad. So if you're interested and if you heard about that or if you have questions about that, I'll be more than happy to talk to you about it. So I've mentioned the authorization server is in charge of returning us a token. And tokens can take many different forms. Like I said, it's just a piece of digital information. So if you're in the Microsoft world, there's WS stuff, which I am absolutely not familiar with. Last time I played with Microsoft technologies was with Visual Basic 6, which was awesome, probably my favorite language ever, but you know, it didn't age well. If you're into XML, SAML is great. It's a way to do tokens, but you know, if you really need to. You can use a custom token. You can use your own little format. So tokens, by definition, they are not defined as part of the spec, so it can really be anything. So I think Salesforce use their own type of token. But the one that is the coolest, in my opinion, is the JSON Web Token. And that's the one we're going to look at. So JSON Web Tokens, there's an official spec that is out there. So RFC 7519, it's in proposed state. And that is very important, because part of this, the RFC, mentions that they should be called JWTs. And it really bugs me. It's just like calling an image a GIF. It just doesn't sound right. So please help me spread the word. It's called a JWT, not a JWT. And I'll eventually try to change the spec before it gets officialized. It's like one of my goals. So JSON Web Tokens are used to exchange information between the machines. So like I said, you can use them as an identity token, which will have information about your users, or you can use them as an access token, which will contain some information about the permissions of the users and so on. In this case, it becomes the key to the API. So let's take a look at what exactly is a JSON Web Token. So it looks like this. As you can see, it's just a little string. And it's nice. It's a nice string. It's very easy to ship around because there's no special characters in there, so you can pass that as part of your headers, as part of your URL. It's fairly lightweight. It's not that big, as opposed to SAML, which is like huge monsters. So that's interesting, but it doesn't tell us a lot of information when you look at it, right? So what we need to know is that there are 3 parts. They're separated by a dot here. So you can see that the first part in orange is the header, then there's the payload, and a signature at the end. Let's take a look at the header specifically. So the header is the orange part here. And this is actually a base 64 encoded string. So if you use your browser's built-in function A to B, and you just pass it this string, you will get a JSON object. So JSON is wonderful. It can be manipulated by most modern languages, so you can actually already have access to some data. In the header, we have the information that describes this object. So in this case, we have an object of type JWT, and we have the signing algorithm, which is HS256 in our case. Second part of the JSON Web Token is the payload. So the payload is also a base 64 encoded string. So if we run the A to B function once again, we will get all of the information that is in our payload, or in our JSON Web Token. There's a lot of different things that you could put there. You could put pretty much whatever you want. There's a few reserved keywords, and they call those claims. It's just a key value pair, no more than that, but they're called claims. So sub is a claim. That's a reserved one. It is who is this token about. In most cases, it will be your user ID. IAT is another reserved one. It's the issued at timestamp. There's a bunch of them, and I'm going to come back to those later. But apart from those very specifically reserved keywords, and those typically have 3 characters, you can use whatever you want. So you can put some information. You could put the name of your user here. You could put I don't know, the different permissions of your user. So really, it's pretty much up to you. It's oftentimes used to store the permissions. You'll have a scope claim, typically, and it will contain the different permissions of the user. Finally, we have a signature. So this little part is not a base64 encoded string. In this case, it's an 8-MAC SHA-256 signature. So it's just a signature that is generated. A signature is we take a string and we just encode that in a unidirectional way. So there's no way to actually decode the signature. And it generates a unique string based on the information that we've passed it. So in this case, we'll generate a signature based on the header and the payload, and we'll also give it a secret key. So it will take that secret key to magically do something. So how do we use JSON Web Tokens to secure our applications? So let's take a look at an authorization server. This is probably the simplest authorization server that I was able to build that would fit into a slide. Don't use that in production, please. But it kind of gives you an idea of how things are working. So I'll have 2 different endpoints on my authorization server. So the browser, once redirected, will be able to do a get on my authorization server to get an authentication form, so just a login form. And once I click on submit, it will just send data through a post request to the login route. And we'll validate if the user is who he says he is, if he has the right password. And if he is, we redirect back to the application, the original application that brought us here, and we'll append the JSON Web Token to that. Who's a JavaScript Node.js developer? There's a few, maybe 25%. I'm using examples here in JavaScript. It could be used in anything. I'm using Express. It's just a way to build a web server in Node.js. I like it because the language is relatively easy to understand, even if you're not familiar with JavaScript. Still, I'll describe what's going on here. So I get, and I'm just going through the post to the /login part. So what I'll do, the first thing, once I receive a post, I'll validate if this is a valid request, right? Do I have a username? Do I have a password? If not, I can already send a 400 and reject that request. Once I've validated that, I can do a search in my database to try to find a matching user. Of course, my database here has plain text passwords, so it makes it really, really easy to find a user. So, like I said, don't use this in production. So if you don't have a matching user, we can return a 401. Very important, and I'd like to just do a little parenthesis around that, but always return the same error message depending on, it doesn't matter if you don't have a matching user or if you don't have a matching password, always return the same one, saying user invalid or user not found or whatever it is for privacy reasons. So you should never say this user does not exist in our database. And finally, if we have a matching user in our database, then we can generate a JSON Web Token. So in this case, I'm going to use the JSON Web Token library available on NPM. So it's just a module that you can load into your Node script. And I'll use the sign method. So I just pass it the payload that I want, and I give it a secret key. And it will take care of generating the JSON Web Token for me. Once I have my JSON Web Token, I redirect back to my original application, and I append my access token. So my application will be able to take that and use that in future requests to the API. On the front end, we're not going to go through each one of the major frameworks, but the only thing that you need to do is to add an authorization header to your request. So you add authorization, you say bearer, and you pass it a token. If there is a token and if it's a valid one, then the request should be accepted. If there's no token, the request should be declined. On the API side, I'll have a route here, which is for some admin data. So I'll get an incoming request. I'll check if in my request there is an authorization header. If there's not, I can already stop the request right there, send back a 401. If I do have a JSON Web Token, I'll take that, I'll split into different parts, I'll extract the payload, I'll decode this. This is a node implementation, so I don't have the A to B function, so I'm using the buffer from. But essentially, I'm just doing the same thing as I've shown before. So converting back from the base64 encoded string. And then I'll check if the user has admin permissions. If he does, and it's just a Boolean in my payload that I'm expecting, if he does, I'll say, yeah, congratulations, you have admin rights. If he doesn't, I'll be sending a 400. All right, so let's take a look at all of this code. Let's see if it actually works. So I have my login. So I'm in my application, which is my slides. So I'll log in. I'm redirected to an ugly little authorization server. And I'll try to authenticate here. This is not the same password as I use everywhere, so don't try that. Not that I use the same password everywhere. OK, so I've authenticated on my authorization server, and I'm redirected back to my slides or to my application. And it passed me the access token as part of the request, so now I could extract that, and I have this access token. So I'll just store this for our future slides. Let's just decode that. So in here, we have the user ID using the subclaim. I have an admin to false, because this user is not an admin on the system. I got the username, and we've got a few things. So let's try to connect to the API using this JSON Web Token. So first thing, if I just try to do the request, I'm getting a no authorization server, which is good. So I'm not authenticated. I do not have access to that data. That's good. It works. So I'll just take my JSON Web Token. I'll append that as part of one of my headers to the outgoing request. And I'm getting a 400 because I don't have admin permissions. I love HTTP cats. I use them in all my presentations, specifically that one. So, so it tells me that I'm not admin, and who is he to tell me that I am not an admin? So I'll try to prove him wrong. So let's just take a look. Right, I will need my JSON Web Token here. That big enough? Like this. All right, is that good in the back? Cool. All right, so I've got my JSON Web Token. Let's see if I can, I'll take the 3 different parts. So I'll just do a split. All right, so now I should have my payload in part number 1. All right, so this is the payload of my JSON Web Token. Makes sense, but not very useful so far. So let's try to use the A to B function here to convert that. And I've got a string. So I can see that I have access to the objects. Unfortunately, it's in a string, so let's just convert that to a JSON object. OK, so I have my JSON object. I have access to the payload of my JSON Web Token. Like I said, I want to be an admin, so I'll do payload.admin equals true. Ha, in your face. All right, so let's re-encode all of that. I can never type that word, stringify. All right, and I'll reconvert that to a base64 encoded string. Got it. I'll put that back in my token. There it is. And JWT. Boom, there we go. So we have our new JSON Web Token here. Can take that. So we have our original one, so no authorization header found, not an admin. Paste in my new JSON Web Token, and boom, I've got admin rights. So not very secure. So pitfall number 1 is the no signature check. The signature is the most important part, or yeah, probably the most important part of your JSON Web Token. So remember that little part at the end that I've mentioned. That is what prevents you from tampering or prevents anyone from tampering with your JSON Web Tokens. So what you'll do when you always need to check them. It's very easy to check, actually. So what you'll do once you actually get the incoming JSON Web Token, you will take the header and the payload, and you will check what is the algorithm that is being used for the signature. So as you've seen in the header, it said HS256, so that's what I'm going to check for. And then I'm going to generate a signature on the API. So I'm going to take the header, the payload, as well as the secret key, which is shared between the API and the authorization server. And I'll generate a new key here. You cannot decode a signature, so you'll try to generate a new one. And then you'll check if the one that you've just generated on the API matches the one that was created on the authorization server. If there's a match, that means that it's a valid token. If they don't match, then that means that the token has been tampered with at some point, so you should reject those. So this might be an obvious one, but it's not always enforced. So that's something that you should always check. So now I had my no authorization header found. That was the original one. The one that I've hacked gives me an invalid signature. So I've changed my API, I've implemented those changes, and now I can check if somebody tampered with my JSON Web Token. Cool. I've built myself just a little JSON Web Token editor to make it simpler here. If you ever have to play with JSON Web Tokens, there's a great resource called JWT.io. You should definitely look it up. I'll share it at the end with my, when I share my slides. So I had my JSON Web Token here, so we'll just decode that. So I've got my header, my payload, my signature. So like I said, I really want to be an admin. So I'll change this to admin. Now we know that it won't work because we have the signature check. So let's see if we can change the algorithm for the signature to none. Re-encode this. We can see that we don't have a signature now part of our JSON Web Token. And guess what? I've got admin rights again. So what happened here? Also, another current, very common pitfall, the AlgorithmNun attack. So, and it's a strange one, but AlgorithmNun is part of the standard. It's part of the standard for JSON Web Tokens, and it can be very useful in very specific cases. If you're doing some IoT stuff, you've got a tiny, tiny, tiny microcontroller that doesn't have any computational power. Basically, you just want to make sure that you pass some data to it. Maybe you won't want to generate a signature if you know that this channel is absolutely secure and nobody can tamper with that data. So it's very useful for that. And it's part of the actual standard, it's part of the RFC, but if you don't accept that, make sure that you actually enforce it. Make sure that you check if the token has an algorithm of none. If it does, you should immediately reject that. All right, let's take a look at another common pitfall. So let's load our JSON Web Token here and click here. Now, if you're sitting in the front rows, you'll probably start hearing the fans going on. It's probably going to heat up a little bit, and it takes a few seconds. And we found the key. So we now know that our secret key is ABCD. We found that in 19 seconds, so it was relatively fast. If you're interested, the code is like super simple, and it's on CodePen. So there's a link up there. Not that you can actually read it, but it will be part of the resources at the end. So hey, what happened? I can actually find the secret key without having knowledge of it. So it's not very secret, is it? And now that I have the secret key, I can actually change those to true again. Type in the secret key, generate a new JSON Web Token, and actually get my admin rights again. So pitfall number 3, weak secret keys. So if you have to use HMAC or SHA-256, be very careful about that. So signatures should be, one, kept secret. Never, never, never store them in your front end. So don't try to validate a JSON Web Token in your front end. Keep those on the API and on the authorization server only. So there's no way to validate the authenticity of the JSON Web Token in the front end, but you can do that in your API. So make sure that you keep it secret for starters, because if somebody has access to it, he can generate a valid signature and then tamper with your tokens. Signatures are meant to be relatively easy to compute. It's just some math operations that are being done on a large string, and it gives you a result of this very specific string, unique to whatever information that you've tried to sign. They are meant to be easy to compute, so you can do multiple stuff with it, and you can easily verify if some data has been tampered with or not. But because it's so easy to generate, you can actually generate a gazillion of them within a fraction of a second if you have the right library, and there is one that exists, which will use your GPU to generate all of those. So that is by design, but it's also one of the biggest flaws. So if you absolutely need to use SHA-256, make sure that you use strong, very, very strong keys, at least 64 characters, mix up everything, lowercase letter, uppercase, whatever, special characters. Make sure it's random if you can. Don't use dictionary words. So they're also part of the library that you can use to brute force them. So make sure that you use very, very strong keys, or ideally try to use an RSA public-private key pair. So I'll change my server here. I'll change my API. I'll make sure that I use a more secure key in the future. So it's not a big change. It's just making sure that the secret key that you share between the two servers is actually very long and secure. Cool. All right, so now what I'll try to do is that I'll try to log into a completely different, more secure server. So I'll just log in here. We can see that it's much more secure because it says so at the top. On this server, I have admin rights, which is, yeah, not very secure because it says it there. And this authorization server knows absolutely nothing about the API that we're trying to connect to. But I do have admin rights on it. You can definitely see how secure it is because it actually uses a password field. I think I got it. All right. OK. So this new authorization server, which is meant for a completely different API, will return me a JSON Web Token in this case. And I can decode the information, so I can see that I'm an admin. I have my username is Joel Lord. This token was issued by a more secure authorization server, and so on. So now if I go back to my original API, I can do a request, and I'm admin. So I had no effort to do. I just reused a token that I had on another authorization server, and I was able to use this on this API. So that's another very common pitfall. It's a little bit more complicated than that, because you also need to tamper with some of the signature things. But essentially, it breaks down to this. It's when you use something where you have some permissions on a different system, and you try to reuse that on another machine, and it actually lets you in. So confused deputy problems, something that you need to be aware of. Some of the little tricks that you can use to help with that is using all the different extra claims that you have in the JSON Web Token. So ISS is one that is often used for the issuer of the token. So it specifies who is the authorization server that just issued that token. So in the second example, you've seen that my payload was a little bit longer, and it said ISS, the more secure server. AUD is the audience. Also a good thing to check, who is this token meant for? So if you're the API, you want to check if this token is meant for you. If it's not, you can reject it. Also, the expiry timestamp, something that you should always check. And it's an easy check, so you can actually do it on the front end as well. So make sure that this JSON Web Token is still valid. So if you want to check this, you just take your payload, check the ISS, make sure that this is meant for the ugly little authorization server, and that is also made for the simple API. So now if I try to use the token that I just got, I'm getting a message that says, I don't trust this server. So this is not the server that I was expecting, so you can already reject those requests. You can also check the audience, which is pretty much the same thing. It'll check if this is meant for this very specific API. If it's not, you will reject and send back an error message to the users. All right. And now we have pitfall number 5, our last pitfall that we are going to see. And I didn't show a demo. That's because something actually happened here. So if I look at my code, I've got a message that says, this is some malicious code logging my JSON Web Token. So what happened here? So in this very specific example, what happened is that I have a malicious library somewhere in my code that was actually able to read the local storage. So you remember when I clicked on the button that said store a token, it made it easier for me to use it on different slides. But by storing it there, there's a library somewhere that was actually taking a look into my local storage and found it, and thankfully only logged it in my console. Also, I know the author. So that's easy, but if it would be some code made by somebody with malicious intents, they could send the token over to somebody, to another server, and then they would be able to impersonate your users. So no storage is safe ever. Don't persist your JSON Web Tokens anywhere if you can. If you absolutely need to, local storage is the safest way to store a JSON Web Token. But make sure that you read every single line in your node module folder or any external library that you import into your project. And I know for a fact that nobody will ever do that, so just don't store them. The easiest way is to keep them in memory. By keeping them in memory, it's a lot harder for external libraries or to malicious code to actually access it. So if you're using something like React, you can store it in your Redux store. It doesn't store it physically, well, not physically, but it doesn't persist it anywhere on the disk. That makes it a lot safer. The downside to that is that if the user refreshes, then you lose the content in memory, so you lose the access token, so you might have to log back in again. There's also a bunch of different attack vectors that are out there. There's a bunch of things that you should check. I've mentioned very quickly the expiry timestamp. That's an easy one that you should always check. Some JSON Web Tokens are meant for a one-time usage. If that's the case, make sure that you actually enforce that. It doesn't come out of the box. It doesn't happen magically. If you have to revoke your JSON Web Tokens, you also have to check that if the JSON Web Token is not in a blacklist or if it hasn't been revoked. There's also the elliptic curve attack, which is very interesting. It has to do with the maths and a way to generate a signature, but it can actually be hacked as well, so we have to be careful if you're using that type of signature. And we're only talking about the JSON Web Tokens at this point. So ensuring that your servers are actually very secure is a lot of work, so be careful if you want to build your own. I'll leave you with some of the best practices. Simply using JSON Web Tokens does not make your system secure. The fact that you're using a JSON Web Token does in no way prove that your system is secure. Actually, maybe all of your data is still very easily accessible as long as you pass in an authorization header. If you deal with JSON Web Tokens, use libraries that have been made already. JWT.io has a bunch of them. They list all of those libraries that they've checked and they know are working. They will show you which algorithms they support and so on. If you are building a server, sometimes there's, especially in Node, there are some middlewares that are available, so you can just plug them in and it will validate every single request that comes in. And that will take care of a lot of the work for you. If you can, when you're using signature, try to use the RSA private-public key pairs. It's a little bit more complex, it's a little bit more code, and it doesn't fit in a slide, hence me not showing it in an example, but it is a lot more secure. So until we have quantum computing up to the point where we want it to be, there's no way to actually be able to hack a RSA, a private-public key pair. And finally, try to use trusted third-party resources whenever you can. I mean, if you're alone, you're working on a project, maybe you don't want to take care of building your own authorization server and all that stuff. There are some that are available to you. All the major players in social media have their authorization server open for you, and you can use that. So you can use Google servers and Facebook servers, and you just have a button that says login using Facebook. It makes your job as a developer much easier, and it makes the information of your users much more secure as well. Some resources, JWT.io, the website that I've been talking about. CodePen, the example that I've used for brute forcing the key. I thought it was an interesting one, so I wanted to share it there. And finally, there's a blog post that basically describes all of what I've just said, plus a lot more, which was written by Sebastian Parrott, one of our content authors at Auth0. Great blog post. So thank you very much for attending.